السلام عليكم، نيلو هنايا. اليوم غادي نكملو داكشي اللي بدينا الحصه الفايته في مدخل الجبر الخطي or Linear Algebra اللي غادي تفيدكم بالنسبه لاي واحد باغي يتعلم ماشين ليرنين. المره الفايته كنا وقفنا تنهضروا على tensors. قلنا tensors هو تعميم ديال المصفوفات اللي دايمنشن ديالهم أكبر من أو تساوي 2. Therefore, matrices هما special case ديال التنصر. باش نإلوستريو التنصر، why do we need التنصر؟ كنا هضرنا على pictures شي تصويرة هي is made out of pixels. This is a picture. هذه ديجا مصفوفة two dimensions، ولكن إذا خدينا بأنه each pixel can be represented by a 3-axed values the RGB red, green and blue. For example هنايا غادي تولي عندنا هذه ثلاثية الأبعاد على 2 الأبعاد هي 5 الأبعاد. أولا مثلا تخيل مثلا تتراقب واحد العينة ديال الناس people، واحد المجموعة ديال الناس، وهاد الناس كاين في الخريطة، كاين في العالم. عندنا coordinates، هادو coordinates geographical coordinates، انت تتراقبهم تيتحركوا. هذا people person number 1 person number 2، واحد العينة a sample of people. Let's call it A, B. Person A or B are not only moving in geographical settings, but they are also evolving in time. هذه هي third dimension. Also, these people when we are observing them ملي تتلاحظهم تجمع لهم observations أو ملاحظات اللي هما عبارة على مثلا تخيلهم هما a feature vector could be for example revenue, could be for example expenses or consumption. marital status، شوف واش نتزوجوا ولا لا، واش تيتبدل marital status by time and by geography. And you can imagine more dimensions and add more dimensions, and this observation can be represented by a tensor. Okay, دابا غادي نهضروا على operations that we can do بهاد الكريتشرز ديالنا. creatures اللي قشنا so far are scalar, vector, matrix. Operations on tensor are rare, therefore ما غاديش نديروهم. when scalars operations اللي كاينين we have transpose. هنا dimensions ديال هاد المخلوقات ديالنا، هذا الدايمنشن ديالو is 1، هذا الدايمنشن ديالو is in 1، هذه while n is in natural numbers، وهنايا هذه dimension dimension ديالو is n m. n is a number of rows وهذا number of columns. alright. نبداو في transpose. let's for example have x be مثلا in R, a scalar from R. when we transpose a scalar it's equal, it's the notation, la notation تنديرو هكا to mean it's x transposed, it equals x. let's V be a vector of R n, which we can نحطو vector ديالنا as follow v1 to vn. هنايا n it should not be null. when we transpose a vector it equals this, a column transposed to a row. okay. دابا matrix. let's M be in the space of matrices, مجموعة المصفوفات اللي من dimension n m ديال الأعداد الحقيقية. m could be نقدرو نكتبوها على هذا الشكل m1 1 ديال m1 m mn1 to mnm. okay. when we transpose a matrix here each column becomes a row. هي هذا الكولوم تنشدها ونردها row. هي m1 1 to mn1 وهنايا ainsi de suite حتى السطر the last row is the last column. m. what we will be observing is that diagonal elements will be always the same. الأعداد اللي موجودة على diagonal will be always the same. also there is a rule m transpose equals m. next operation is addition. addition is pretty trivial for scalars. if a and b belong to R هذا is the usual, the addition here e plus b, the sum of them. if we have e and b who are in Rn, they are vectors, then a plus b equals eg plus bg for G from 1 to n. Now, if we have two matrices M and N from M إذا كان خاصكم درس على المجموعات، مثلا هذه المجموعة نديره the sum of M plus N E G equals M E G plus M N E G, quel que soit, whatever is E and G from 1 to n. This is addition. It's pretty trivial. Now let's move to multiplication. First case ديال multiplication here when we multiply, for example, a scalar A to a vector. شنو تعطينا؟ It will give us a vector where all the elements are multiplied by A. If we multiply A to a matrix, also all the elements of this matrix will be multiplied by this scalar. Now let's move to if we multiply a vector to a matrix. And here we have a condition. خاص the number of columns in V should be the same as the number of rows in M. I will explain it. This multiplication will be only possible if we have this form. Here V1 till Vn multiplied by M1 1 to M1 N M1 M M N M. How we do this product, how we do calculate this product, it's we take each element, we multiply it to the corresponding element in this column, and we do the addition. For example, here we're gonna have a vector. The first element is V1 multiplied by M1 plus V2 multiplied by M I'm sorry, here we invert by M2 1 ainsi de suite till Vn multiplied by Mn1. We can continue this till Vn multiplied by we continue the same. It's V1 multiplied by M1M plus V2 multiplied by V2 by M2M plus till Vn multiplied by Mnm. This is a vector of n. I'm gonna try to write it in in a short manner. The same product will be equal to the sum of VG multiplied by MG1 from G equals to 1 till N, and we go this way till VG M MG M. That's it, it's a vector. Now how we calculate the product of two matrices. For example, matrix 1 and matrix 2. Let's generalize. The only way this product is gonna be possible is with number of columns in M1 is equal to the number of rows in M2. So it's gonna be, let's change the names of this to avoid any confusion. It's gonna be like the product of A and B. They are matrices, and we're gonna write them in their في الشكل ديالهم المنشور. It's gonna be A1 till A. We're gonna agree to give them the same number of columns. The same number of columns in A. N is gonna be the same number of rows in B. Till A1 K, for example, till A, it's not 1K, it's K1 Kn multiplied by B11 till B1M, and dimension, it's gonna be N B N M. The product of these matrices is gonna be as follow. I will write it in the aggregate form because it's easily understood. تقدر تفهموها أحسن ما إلا نشرتها. هي بنفس الطريقة. It's the scalar product of each vector. هيكون عندي هنايا A, for example A multiplied by B is gonna give you the sum of the product of each row in E For example, here we're gonna have 2EG, B is gonna be G, K, we're gonna sum on G 1 to N, the common it's gonna give us here the EK element. So the matrix that's gonna result from the product of a matrix of size what we see here is gonna be a matrix of size Kn and this one is n m. It's gonna be a matrix of size k m. And that's it. Next time we're gonna talk more about other operations, and we're gonna move forward a little bit faster. Thank you.